Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that evaluate the following integrals. These are the integrals. Now, let's analyze these integrals. The integrand, the one where the function we are supposed to integrate. You can see that all these functions, you cannot solve them by direct integration method. This one, you can't solve it by direct integration. Likewise, this one and this one. You need this one, obviously, you have to use the substitution method to solve this one. This one also, and also this one. So, if you are given an integration, if you are given a function to integrate, you have to analyze it to know the kind of integration you are going to do. So, all these functions, you have to use simple substitution technique to integrate them. So, let's do this. The first one, integral of sine 3x x. Now, this kind of function, you integrate it using substitution, and we will integrate this function using substitution method, but there's also a shortcut you can do it. So this is given that for integral of f(ax) dx will be equals to 1 over a f ax plus c. So what this means is that when you are given a function like this resembles this. You know, ax is 3x, then f is sine. If you are given this kind of function, you differentiate this inside, the inside one, the one in bracket, which is 3x, which is ax. When you differentiate it, you divide the whole function by that value. The derivative of ax is a, so you divide 1 over a times, then you integrate the outside function, which represents f, capital letter F. It's in a way, it's like a composite function when we are doing differentiation. But in this one, the only difference between this one and that, and when we are differentiating, in differentiation you multiply what you get here by the function, but in this one we are going to divide the function by it. That is why we say 1 over a. Then if here is sine, it will become the integral of sine is what? Is negative cos. So we write negative cos here. So it will be 1 over a negative cos. Then you write the value 3x or ax. So now you are going to differentiate this one in bracket. You put 1 over that, the value you get, then you integrate the outside function, which represents f, capital letter F. And then you put the function back in bracket plus c. So in this one, we can even use this method to integrate it. We will just say derivative of 3x is 3. So it will be, say 1 over 3 times sine, the integral of sine is what? Is negative cos. So it will be negative 1 over 3 cos 3x. That's the answer. But I want to show you the longer method. This one you can use it during OBJ or CBT exams. But let me show you the actual longer method. Now we'll substitute. We'll use the substitution method. So we'll say you can use any variable, but I like using t. So let t equals to 3x. Then you differentiate this. It's the same thing, but the longer method is the longer method. Actually, this one most lecturers prefer this one in doing AC exams. So you substitute this value 3x. So then you differentiate it. It's the same as when solving function of a function in differentiation. With a little difference, with a little difference here. So the t dx is what? Is 3. You see the derivative we did here, ax, a. So it's 3. Then now, we will make the x the subject of the formula here. So the x now becomes what? We cross multiply dx, 3 dx equals to dt. So the x now become 1 over 3 dt. So we have made the x the subject of the formula. Then we can substitute it back in this equation, since there is no more variable for x. So it will be integral of sine t. Then the x is what? 1 over 3 dt. So our goal is to eliminate x from this equation. So everything will be in terms of t instead of in terms of x, or in terms of any variable you use. So now we factorize the constant 1 over 3, or we take out the constant, it becomes sine t dt. So now, what's the integral of sine t? It's 1 over 3. The integral of sine t is what? It's negative cos t. Then plus c. So now the answer it becomes minus 1 over 3 cos t plus c. Then what is t? T is sine x, is 3x. So it becomes minus 1 over 3 cos 3x plus c. So this is the answer. This is the integral. So now here is the integral of this, of the function that was given. And you can see that it's similar to what we got at the beginning from using the shortcut. So we'll just differentiate this. You differentiate 3x, you get what? You get 3. So 1 over 3. You see? Then integrate the outside function, which is sine. Sine is what? The integral of sine is what? Negative cos. Then you put 3x. Negative cos 3x. So this becomes negative cos 3x. Then if you multiply them, you get negative 1 over 3 cos 3x plus c. So that one is a shortcut you can use during CBT or OBJ exams. Well, this one is for AC exams. So let's move to the second one. So here's the second one. In the same way, we are going to substitute it. We'll say t let t equals to 5x. Then dt over the x is what? Is 5. Then we'll make the x the subject of the formula, which becomes what? The x now will be equal to what? When you multiply the x by 5, you get what? 5 dx. So you divide both sides by t to become 1 over 5 dt. So dx will be equal to 1 over 5 dt. Then what next? We are going to substitute t in this equation. You get 8 x squared t. Then the x is what? 1 over 5 dt. So this becomes, we factor out the constant to be 8 over 5, because 8 will come out times 1 over 5, which is 8 over 5. Integral of sec squared t dt. So what's the integral of sec squared t? The integral of sec squared t is what? The integral of sec squared t is tan t. So it will become 8 over 5 tan t plus c. Now we'll substitute t here. The integral becomes 8 over 5 tan 5x plus c. And this is the answer. You can also use the shortcut to confirm it. So now if we use the shortcut method to confirm whether this is actually correct, we'll say we'll differentiate this 5x to give us 5. So here is 8 to be factored out. So 8 now becomes 8 over 5. So this now becomes 8 over 5. Then now, what's the integral of sec square? The integral of sec square is what? Is tan. So you put tan, then 5x. So that's it. So this is correct. So then the last one, let's move to the last one. So now here's the third one, the third integral. Now, to substitute, most people confuse the one we are going to substitute as your variable, maybe t or any variable you choose. But what you are supposed to do is you have to look at the function. You know, it's not like function of a function in differentiation that we take all the function and we substitute it as a variable. No, in this one we only take one of the functions. You don't take all the functions like in differentiation, composite functions, like when substituting in composite functions in differentiation, whereby if it were y equals to this function all squared, you will take the function inside the core as the whole variable. You substitute it to your whole variable, maybe t. You say t is equal to the whole of this. No, it's not like that in integration. Integration, you only choose one function, whereby if you differentiate that function, you are going to cancel the other values of x in that function. So now in this one, if I take t as 4x now, when I differentiate 4x, I'll get 4. And 4 will not cancel any other function of x. But if I take x squared plus 4 now, if I differentiate this, I'll get 2x. So the x that remains will cancel this x that is above. So you have to, when substituting, when doing integration by substitution method, you have to think of a function that if I carry and I differentiate that function, it will cancel the other values of x in that function. Don't just take any function as your t. It's very important the function you take. The function you take depends on whether you'll be able to solve that question or not. So we will take the denominator as our t. It's not like differentiation whereby you substitute the whole function. No, in this one you only take one that will cancel the other, the value of x in the other one. So I will say let t equals to x squared plus 4. So now we'll differentiate this. It becomes what? The t over the x is equals to 2x plus 0. So now we'll make, in this one, normally we make the x the subject of the formula. But since there's x here, to make this easy for ourselves, we can make x the subject of the formula. So this will now become, we'll make x the subject of the formula. So we'll cross multiply, it becomes 2x x is equals to the t. So now x will be equals to 1 over 2 dt. So we have made x the subject of the formula. Now in this one, we have successfully cancelled x. In this function now, we have successfully cancelled x. So now we can substitute t here to become, this one will go, what will represent it is half the t. So it will be 4 over t, since this one is t, then times half the t. So we want to express all this equation, all this function in terms of t now. That is why we're looking for a function that will cancel x, so there will not be x here. So if there's x here, we cannot solve this. So now it's all in terms of t. So it will become, we'll factor out the constants, it will be 4 over 2, so 2, then 1 over t, the t. So now this becomes what? 2, the integral of 1 over t is what? Is ln t. 2 ln t plus c. So this becomes, what's t? T is x squared plus 4. So this becomes 2 ln x squared plus 4. Then plus c. So this is the final answer. So this is the integral of this function. And you can see that in this function, there's no way we can use direct integration to solve this. It's impossible. So this is only substitution that we can use here. So we have evaluated all the integrals given to us in this question. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email within the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.